Assalamualaikum everyone. In this video we'll see how to form a partial differential equation. Okay, in the previous video we saw an introduction to PDE, what is actually a PDE. Now in this video we'll see how to form a partial differential equation. Okay, before that in the last class, in the previous video we saw this z is a function of x comma y, right? We said this z is a function of x comma y. What does this mean? Z will be any function in terms of x and y. For example, z is equals to x square plus y square. Okay, here I've got an x term and y term, right? So z is a function in terms of x and y. One more example can be z is equals to 2ax plus 3by plus 1 anything, okay? Or else one more, it can be also in the form of logarithms, 1 by log a plus x by 2 log b plus y by 1 minus log x, anything, okay? So here if you see, my z is in terms of what? Only x and y, right? My x is in terms of x and my z is in terms of x and y. Z is a function that is in terms of x and y. Okay, so let me just erase this. Okay, so z is a function of x and y, we told. Now what? We are doing partial differentiation, right? So that means what? I need to differentiate this z with respect to x once. Then I need to differentiate this z with respect to y because I've got two variables here. One is x and one is y. Suppose I've got ub. So I'll differentiate with respect to u, then with respect to v. So when I am differentiating with respect to one variable, the other will remain a constant. Okay? If I am differentiating with respect to x, y constant रहता. ठीक है? अगर मैं y से differentiate कर रही हूँ तो मेरा x क्या हो जाता? Constant हो जाता. ठीक है? Okay, moving on. Okay, so let's see if I differentiate with respect to x. So this will be dou by dou x. With respect to x I'm doing, right? So dou by dou x of z, or simply I can write it dou z by dou x, one and the same. Dou z by dou x or dou by dou x of z, one and the same. So this is when I am differentiating this z with respect to x. Okay, suppose if this equation I am differentiating it with respect to y, this will be dou z by dou y, right? Now suppose this equation z, if I am differentiating it with respect to x two times, this is once done. If I am again differentiating it further, it will be what? Dou square z by dou x square, right? Isn't it? Now similarly, if I differentiate with respect to y two times, the same equation, for example, so this will become what? For once, if I do it once, I'll get this dou z by dou y. If I do it twice, what will I get? Dou square z by dou y square. Okay, suppose if I differentiate this equation with respect to x and y both together at a time, this is, I'm doing it individually. If I'm differentiating it together, okay, so what will I get? X and y together, what will I get? Differentiating with x as well as differentiating with y. So what's happening here? Two times difference, दो का differentiation is happening, right? So I'll get two times dou z. So instead of writing it like this, dou z into dou z, I'll write dou square z. Okay, because it's happening two times. So dou square z by dou x into dou y, because here I'm differentiating with respect to x and y together. Okay, I think this is clear. So now, okay, so see, writing dou z by dou x, dou z by dou y, dou square z by dou x square all the time will be a little confusing, right? While reading it won't be very readable, right? So instead what I'll do, I'll represent them with some alphabets. Okay, so dou z by dou x is represented with P, dou z by dou y is represented with Q, dou square z by dou x square is represented with R, dou square z by dou y square is represented with T, and this is represented with S. मतलब क्या है इसका is wherever I find dou z by dou x, instead of writing dou z by dou x too many times, I can write P instead. Okay. Similarly, instead of writing dou z by dou y, I can write Q. It is simple to write, right? So similarly for this, and this, these are the representations. We need to remember this. Okay. So yeah, in while doing our calculations, while doing our derivations, wherever we find this terms, this partial differentials, we'll write the alphabet, the letters instead of them. Okay, clear? Now moving on to formation of partial differential equation. ठीक है, how are we going to form a partial differential equation? We'll be given a simple equation, a random equation. Equation has what? LHS and RHS, isn't it? एक इक्वेशन दिया हुआ रहता है आपको, उसमें से आपको जो है सो पार्शियल डिफरेंशियल इक्वेशन डिराइव करना है बोलो आप, या फॉर्म करना है बोलो, वन एंड द सेम. ठीक है, एक इक्वेशन में से आपको पार्शियल डिफरेंशियल इक्वेशन फॉर्म करना है. कैसा करना है? यू हैव गॉट टू डिफरेंट मेथड्स. एक है बाय एलिमिनेटिंग द आर्बिट्री कांस्टेंट्स एंड द अदर इज एलिमिनेटिंग द आर्बिट्री फंक्शंस. फॉर एग्जांपल सी, सपोज आई हैव अ फंक्शन in terms of x, in terms of y, in terms of z, a and b. ठीक है, suppose कोई एक function है मेरे पास in terms of all these things. So here if you see, this a and b are what? Constants. This x and y are what? Variables. Okay, and this z we just saw, it is a function in terms of x and y. ठीक है, suppose मेरे पास एक function in terms of x, y, z, a, b. So a, b here are constants, x, y are variables, and z is a function in terms of x and y that we just saw. Okay, so for forming a partial differential equation from this, what I need to do? I got two different methods. One is eliminating the constants, the other is eliminating the functions. Either I'll eliminate this constants or I'll eliminate this functions and form a what? Partial differential equation. ठीक है, for definition it is like simple only. आपको एक इक्वेशन में से पार्शियल डिफरेंशियल इक्वेशन फाइंड करना है. दो मेथड्स है, एक मेथड इज बाय एलिमिनेटिंग द कांस्टेंट, द अदर मेथड इज बाय एलिमिनेटिंग फंक्शंस. डन. Okay, let's see some example on this so that it will be clear for us. ठीक है, how to do it. Let me just erase this. Okay, let's see the first method, that is eliminating the arbitrary constant. Suppose this is my question, z is equals to ax plus by plus a square plus b square. So इसमें arbitrary constants क्या है मेरे? Constants क्या है? This a is my constant, this b is my constant, this a square is my constant, this b square is my constant. So what I need to do in order to form a PDE, I need to eliminate this a, b, a square, b square. Okay, ये नहीं चाहिए मुझे. I need to eliminate this. Okay, so for that what we are doing, we need to अच्छा ठीक है. And secondly we have got two variables, right? One is x and one is y. So what I need to do, first I need to differentiate with respect to x and keeping y constant, and second time what I need to do, I need to differentiate y keeping x constant. Okay, so let's partially differentiate with respect to x. What? This equation. Let this be my equation 1, suppose. Okay, so this is my equation 1 and I'm going to partially differentiate it with respect to x. Okay, so this becomes what? Partially differentiating dou by dou x. What I'm differentiating? Z I'm differentiating. So dou by dou x of z is equal to, what is z now? Dou by dou x as it is. What is z? This entire thing is z. So ax plus by plus a square plus b square. Done. Now let's do this. Dou z by dou x as it is equal to differentiating this entire term now. Here I'm differentiating with respect to what? With respect to x. So x का differentiation is, sorry, x का differentiation is what? 1, right? And a is a coefficient, so it will be as it is, a into x. We know this. This is simple. Plus here by, this term becomes 0. Why? Because I'm keeping the other variable constant. This is y. So the y will be constant when I am differentiating with respect to x. ठीक है? If I don't have any x variable in the remaining terms, then all the terms becomes constants. So yeah, this will be a into x ka differentiation is 1 plus this I don't have any x term, so this will be 0. Similarly, I don't have any x term, this will be 0. I don't have any x term, this will be 0. Right? So what I'm left with? Only a. A into 1 is a. So see, we saw this. Dou z by dou x represents, if we represent this with what? With the symbol p, with the letter p. So this will be p. Dou z by dou x will be p. Is equal to what I'm left with? Only a. So p is equals to a. This means what? Now a is what? P. Okay? A is done. Not a is done. X is done. Differentiating with x is done. Now let's differentiate with respect to y, because I've got two variables. One is x and one is y. So let's differentiate with respect to y. Partially differentiating with respect to y. So this I'm differentiating, no, equation 1. So differentiating with respect to y, dou by dou y. Differentiating what? Z. So dou by dou y of z is equal to dou by dou y of what is z? This entire thing. Writing this entire thing as it is. Okay. Now let's differentiate. Dou z by dou y as it is equals to, here in this case, if I am differentiating with respect to y, x becomes what? Constant. So it will be 0. So other than y, whatever term I find, that will be constant. Okay. So wherever I find y, only that terms I'll be differentiating. So here, moving on, I have a y term here. So y ka differentiation is 1, b as it is, plus. Do I have any, I'm sorry, this is not y square and x square. This is, sorry, a square plus b square. The equation 1. Okay, so do I have any x term here? No. So this will be 0. Do I have any y term here? I'm sorry. Do I have any y term here? No, I don't have it, so it will be 0. Do I have any y term here? No, I don't have it, so it will be 0. Okay. So now, so dou y by dou z is equals to, I am only having what? B. B into 1 is b, obviously. So dou z by dou y, we know this as q. Okay, we represent dou y by dou z by dou y as q. So q is equals to b. Now I got the value of b and the value of a. So what I'll do, I'll substitute this in equation 1, my given equation. So this is z is equal to, what is a? I got p. So p into x, plus what is b? I got q. So q into y. So qy, plus what is a? P square plus q square. P square plus q square. Done. So what happens in this final equation? What happens in this final equation? Do you find any constants here, a and b? No. So what we did, we eliminated the arbitrary constants, right? And we formed a partial differential equation. Partial differential equation कैसा form हो रहा है यहाँ पे? ये p is nothing but my partial differential equation. This q is nothing but my partial differential equation. यही है ना? p is what? Dou z by dou x. ये क्या है आपका? Partial differential equation है, right? And what is q? q is dou z by dou y. This is dou y. What is this? This is a partial differential equation, right? So by eliminating a and b, I formed my partial differential equation. Clear? Let's see one more example. By eliminating the function. This was by eliminating the constants, the method 1. Let's see how to eliminate the functions. Okay, okay, let's see an example of a function. Okay, suppose z is equals to f of x plus y. Here f of x plus y is what? A function. So I need to what? Eliminate function in this. So let this question be my equation 1. What I need to do, I've got two variables, one is x and one is y. So what I'll do, I'll partially differentiate with this equation with respect to x, and then I'll partially differentiate this equation, same equation, with y. Okay, so now first one, with respect to x we are doing, so dou by dou x of what I am differentiating? I'm differentiating z. So dou by dou x of z is equal to dou by dou x of what is z? This function, right? So f of x plus y. We know the differentiation of a function is what? F of x ka differentiation is f dash of x, right? So here I'll consider, this is not x actually, I'll just consider this x. Okay, I'll consider this to be x. So f of x ka differentiation is what? F dash of x. But this is not x, I assume this to be x. This is not actually x. So chain rule differentiation, that means I'll differentiate x plus y again. Okay, why am I differentiating x plus y again? I assume this f of x. So f of x का differentiation is f dash of x, but this is not x, it is x plus y. So again uska differentiation, I think you people know this, okay. So now dou z by dou x is equals to same f dash of x plus y as it is. Now differentiating with respect to x, right? So x ka differentiation is what? 1. So I'm writing 1 plus y acts as a constant. Okay? When I'm differentiating with respect to x, the other variable will act as a constant. So constant ka differentiation is what? 0. Now 1 into f dash of x is f dash of x. I know this dou z by dou x is what? P, right? So P is equal to f dash of x plus y. Done. Let this be my equation 2. Now same equation I'm going to differentiate with respect to y now. So x will be what? A constant. So same thing, dou by dou y I'll get, because differentiating with respect to y. So dou by dou y of z. What is z? It is f dash of x, it is f of x plus y. So f of x plus y is what? Now in this case this will be f of, I'll consider this to be f of y. So f of y ka differentiation is what? F dash of y, isn't it? So I'll consider this as y. So f of y is what? F dash of y. But this is not y, this is x plus y. So I'll again differentiate x plus y. So see here, if I differentiate x plus y with respect to y, so x becomes what? 0. X will act as a constant. So constant ka differentiation is what? 0. And y ka differentiation is what? 1. Right? So this will give me what? Dou z by dou y is equals to f dash of x plus y as it is, into x ka differentiation is 0. It is constant. Constant ka differentiation is 0. Plus y ka differentiation is 1. So I know dou z by dou y is what? Q. So Q is equals to f dash of x plus y. Done. Let this be my equation 3. So clearly we can see here this P and this Q, both are equal, right? These functions are equal. F dash of x plus y, matlab the RHS are equal. So I can equate this, right? P is equals to Q, I can write. So I'm writing P is equals to Q. That's it. This is our required partial differential equation. I can either write directly P is equals to Q, or I can do this. I can divide P by Q. I can divide equation 2 with equation 1. So equation 2 is P is equals to f dash of x plus y, right? And equation 3 is what? Same. Q is equals to f dash of x plus y. So this x plus y, this x plus y gets cancelled. I'll be having what? 1. So P by Q is equals to 1. This Q will be cross multiplied. So I'll get what? P is equals to Q. Same thing. I can directly write P is equals to Q, or I can divide it and do this, okay? Either of the ways. So here we got P is equals to Q. Matlab this is my required partial differential equation. Yahan pe my aim was to eliminate the function. So here, can you find any functions? Can you see any functions? No. You have what? Partial differential terms. This P is a partial differential term. This Q is a partial differential term. Right? Partial differential kaisa bol rahi hu? P is what? Dou z by dou x. Right? P is dou z by dou x, and Q is what? Dou z by dou y. तो ये है क्या? ये terms are what? These are partial differential terms, right? So I formed my partial differential equation, right? So that's it. This is the final answer. I think you understood. Okay? So in the next video, we'll see some more problems regarding this eliminating constants and eliminating functions. For now, I think this topic is clear for you. I've got two methods forming a partial differential equation by two methods. One is eliminating the constants, the other is eliminating the functions. Okay, so that's it for this video. Thank you.